Hi everyone. Today we're gonna learn arithmetic sequence, how to identify arithmetic sequence, how to find nth term in the arithmetic sequence. So how to find nth term of the arithmetic sequence? There could be several different given scenario. So we will explore three different scenario. First one is given sequence. For each sequence, determine whether it appears to be arithmetic. If it does, find the common difference. So first you have to say yes, arithmetic sequence, or no, it's not arithmetic sequence. If it is arithmetic sequence, then you have to find the common difference. So first example, -10, -4, 2, 8. So what you want to do is find the common difference. Common difference, we usually use D as a common difference. Letter term subtract by previous term. So letter term minus previous term. So in this case, -4 minus -10. So you will have to do -4 minus -10. So be careful with the double minus. It will become +10, it will become 6. So difference here is 6. 2 minus -4. 2 minus -4, which also becomes 6. Common difference here is 6. 8 minus 2, that's easy enough. That's just 6. All those differences have to be constant. They have to be same. Arithmetic, yes. What's the common difference? 6. Let's look at the next example. You need to get the difference again. Get the difference between this, which is -8 minus -5, which becomes +5 to -3. Difference here is -3. -11 minus -8, which becomes +8, again -3. So far so good. -14 minus -11 becomes +11 -3 again. So differences are -3 all constant. Yes, arithmetic. Difference is going to be -3. Okay, difference here, 16 -4, which will give you 12 as a difference. 64 minus 16, you can already tell it's not 12. So what's it? 54 minus 6, 53, 48. So difference is a 48. Already the differences are not matching. You don't have to go more, just as long as they are not constant, you can stop right there and say not arithmetic, and you're done. Okay, you should pause the video, try this by yourself, and here are answers for it. Right here are the answers. Okay, next topic. Find the 66th term of the following arithmetic sequence. So if you look at 3, 9, 15, 21, so this is arithmetic sequence, and you're supposed to find 66th term. So this is the formula paper for arithmetic sequence, geometric sequence. And since you're using arithmetic sequence, we will use this column. and that's a series, summation. So this chapter, you will deal with these two formulas here. Explicit rule, recursive rule. So this is the formula you need to use for this particular question. So explicit rule formula, a sub n equal to a sub 1 plus difference, parenthesis, and minus 1. So they already told you each arithmetic sequence. Difference should be 9 minus 3, which becomes 6. 15 minus 9, which is 6. 21 minus 15, which is 6. You don't have to do all these three because they already told you it is arithmetic sequence. So once you get 6, that's a difference. Difference value is 6. 3 is the first element, which is a sub 1. So a sub 1 is 3, first element. Difference is 6. That's all you need for writing explicit form of arithmetic sequence. So a sub n equal to a sub n equal to a sub 1 plus difference, parenthesis, and minus 1. So a sub n equal to a sub 1 value is 3 plus difference is 6. Oop. 6 parenthesis and minus 1. So often your teacher will expect you to simplify this. So which means you have to distribute 6, combine like term, so it'll be 3 plus distribute 6, 6n, 6 times minus 1 minus 6. Now you get to combine like terms here, which becomes 6n minus 3 will be a sub n. So if they ask you find the nth rule, nth term, or rule for nth term, that's gonna be your answer. Here we want you to find 66th term, 66th term, meaning value of n becomes 66. All you have to do, you're finding a sub 66. The value of n becomes 66, meaning you will replace n with 66. Okay, this one I'm going to calculate. So 6 times 66 minus 3. I got 393. That's the final answer for number 3. You should try this question. Pause the video. Try it just like this. And your answer should be something like 4, 524. 524 should be your final answer for question number 3. Next style. Question 5. Find the 13th term of arithmetic sequence. Again, we are giving you the information of the sequence is arithmetic, whose common difference is d equal to 7. So we gave you value of d as a 7. First term is a sub 1 equal to 2. Okay, so this one is exactly same as the previous question, except we already gave you d and a sub 1. You see, we got those information on previous question from looking at the sequence. Well, it's even easier. We already gave it to you. So, same formula you're using, explicit form of arithmetic sequence, you're going to use this. Process will be exactly the same. So, a sub n equal to a sub 1 plus difference, parenthesis, and minus 1. And a sub n equal to a sub 1, value is 2, plug it in, d is 7, parenthesis and -1. Again, you want to simplify, distribute 7, so 7n minus 7. Combine like term, 7n minus 5 will be a sub n. Again, if they are asking for the rule of nth term, this is the rule. We want 13th term, meaning value of n becomes 13. So we are looking for a sub 13, so 7 times 13. You plug it in n value as a 13, then calculate it. Is it 791 minus 5? You can use a calculator. It will become what? 86? 86 will be the final answer. Okay, you should pause the video. Here's a question just like that. Example 6, question 6. Pause it, try it, and the answer for that is 47. If you got it, then you understood. Last style is question number 7. For a given arithmetic sequence, the 29th term is equal to 143, 74th term is equal to 413. Find the value of 8th term of a sub 8. Okay, so we provided this is arithmetic, and a sub 29th term, which is 143, and they gave you a sub 74, which is 413. So the one way you can approach this is think about how many times we are going to add common difference from a sub 29 to a sub 74. So you have a sub 30 here, a sub 31st. You're going to add d here to go to reach a sub 30 from a sub 29. From here, you're going to add d one more time. So a sub 32nd, you're going to add d one more time. So you're going to add d, add d, add d, add d. How many d's do we need to add from here to reach here? It's very simple. Index is 29, index is 74. So you do 74 minus 29 will give you the number of d's we have to add. So the calculation 74 minus 29, subtract that. So 14, which gives you 5, 6, 45. So what does that mean? We're going to add whatever this 29th term is, which is 143. We're going to add d how many times? 45 times. 45d is equal to 413. Because we had d, we had d, we had d 45 times. So this number, which is 29th term plus 45d, is equal to 413. Solve for d. Minus 143 minus 143 gives you a 45d equal to, that becomes 0. 11 minus 4 is 7. 7. And 3, so 270. Okay, divide by 45, divide by 45. D is equal to 6. Right? Yeah, it will be 6. So D is equal to 6. You can use a calculator, of course, if you have it. d equal to 6. Now, what do they want? Find find the value of eighth term. Eighth term. So there are a couple of options here. Eighth term, so you can trace back from here. Eighth term. You might say, well, from eighth term to 29th term, how many d's do we need to add from eighth term to reach 29? Same process. 29 minus 8 will give you what? 21. So starting from here, ace of 8, you will add 21 d's to reach this. So their difference is 21. So you can set up ace of 8, whatever that value is. We're going to add d. We're going to add d 21 times. So 21 times d, which we calculated as 6, becomes 29th term, 143. Then solve for ace of 8. So 6 times 21, which becomes, you can use your calculator again. So 126, ace of 8 plus 126 equal to 143, minus 126 minus 126. So ace of 8 equals to 13, that becomes 7, 3, 1. So ace of 8 becomes 17. And that will be your final answer. Another way to approach this is right here, d equal to 6. You could have found the rule, the nth term. So I can share that with you. D equal to 6, and right then you can use information of a sub 29 being 143 or a sub 74 being 413. So a sub 29 term is 143. So if you use the arithmetic sequence formula, which is this, you can do a sub n equal to a sub 1 plus difference n minus 1. We just found d, which is 6. So you can plug it in 6 here, n minus 1 plus a sub 1 we don't know. And we are using this information now. So if you look at this, a sub 29 value is 143. So value of n becomes 29. So you can plug it in n value as 29 here, 29. A sub 29 equal to a sub 1 plus 6, 29 minus 1. A sub 29 value is 143. So if you plug in 143 is equal to a sub 1. And this one, I'm going to use a calculator. 6 times 28. 6 times 28 becomes 168. Plus 168. Minus 168, minus 168 both sides. So a sub n equal to, what is this? 8 minus 3 is 5. 6 minus 1 is 2. Minus 25 is a sub 1. So once you get the a sub 1, you can update your rule nth term, a sub n equal to a sub 1, which is minus 25, plus difference is 6 and minus 1. You can simplify this expression, distribute by 6, minus 25 plus 6n minus 6. So a sub n equal to 6n minus 31. We found the rule. then you can use that rule to find 8th term. Then you can plug it in 8. So ace of 8, plug it in 8 here. Ace of 8 equal to 6 times 8 minus 31, which becomes 48 minus 31, which is what? 17. Again, I think the first method we did was a lot simpler. So you're welcome to do that. Just get the difference between this and apply it. That will be easier. But if you want to do this way, you can do that too. Whatever is easier for you. You should try this. Pause it, try it, and 8 answer should be minus 133. Okay guys, I will see you next time.